everybody. My name is Frank Ridgich. In this video, we're going to just lay out some of the practicalities of what the course is how it's going to operate in terms of its structure, in terms of the materials we have. So this is going to be just kind of an overview, like of the course, the operations of the course. By the end of this little module, Module 0, you'll be able to understand how this course will be delivered, this mechanism. We're trying something new this year, which is both exciting and terrifying. We're going to talk a little bit about how the flipped structure works, so you'll be able to understand that. And then we'll also talk about how teams are evaluated, so you'll be able to understand that as well. So this is a flipped classroom. It's the first time I've ever attempted such a thing. So the idea of a flipped classroom, which I've heard many good things about, is that we will learn the foundations, or in other words, the theory, before a class. And then we're going to use our class time for kind of live in-person practice and coaching and more sort of interaction. I think this is going to be far better than the kind of standard thing where you come to class and just listen and take notes and ask the occasional question. So there's kind of two phases to this. The first phase is pre-class. I'll be posting videos on a website I'll show you shortly. And you'll basically watch those videos. There might be some links or some extra reading to do. And in that material, there'll also be sort of a quick check most of the time for you to run through yourself and just kind of surface any misconceptions you might have. This will more or less take the form of questions, multiple choice questions, for example. They won't be marked, they're just for your benefit, so you can we make sure that you're understanding the material. Then you bring the knowledge you've gained from that video and that reading. You've brought any questions that you have coming out of that reading and viewing into class. And that's when we discuss those issues, you ask questions, we solve problems together. There's going to be a lot of discussion, a lot of hands-on interactive feedback, and we'll also be applying these ideas to real cases. So it's going to be very hands-on. There'll be lots of code we'll develop together in class, in person, and it'll work in that manner instead of the other way around. I think this is going to work because we'll have much more active time in class, especially. You'll have faster feedback. So, as soon as there's a problem, you ask me, I'll be there. Your peers will be there. It'll be far more direct and immediate. This will also help us kind of focus on the hard parts rather than just passive note-taking. So again, this is going to be a new exercise for me as well, but I think the idea is to kind of use this time we have together in class to push up against what we find challenging. The fact that this is flipped and the fact that we have sort of these things to watch and read at home shouldn't necessarily give you any more work than you already would have in the sort of traditional approach. Rather, we're just moving the lecture and the theory aside so that the class can be more hands-on. So I'll be posting videos like this one throughout the class. They'll be on a website I'll show you in a moment. The idea is that you will watch at your own pace. Ideally, that pace is not like 1.5 times the speed, and ideally, you're focusing on these videos. They'll be generally pretty short. And while you're watching it, you can pause, you can take a break, you can come back. In particular, I recommend pausing at these pencil prompts. So whenever there's most of the time when there's a pencil prompt, I'll kind of suggest that you pause and then you take some notes for yourself. Normally, this is not going to be marked either. This is just something for you to think about actively at home or wherever you're watching these videos, and just to kind of take notes to yourself. I'm going to recommend that you do have a notebook of some kind throughout the class, in which you can take these notes. In which you'd also jot down questions you have from the videos. Anything goes into this kind of standard form of notes. There's many ways you can approach this. There's good old-fashioned paper. There's Obsidian, which is a popular, almost open source note-taking app, which is kind of similar to Notion, which is fairly popular. I use Orgrome, which, let's see if I can click on this. Can you still see my screen? There you go. Orgrome is a kind of a plugin for Emacs, which I'll talk about again in a few moments. Can you still see this? Excellent. One thing I should note also is all of these slides I'm going through will be posted online, and as you've just seen, they're interactive, far more interactive than PowerPoint. They're based on something called Reveal.js and JavaScript and HTML, for what it's worth. There's going to be lots of instances where you can interact with these slides. Generally, it's very important for you to just write things in your own words. This is for your own benefit. Maybe no one else will see these notes that you're taking on paper, Obsidian, or Chrome elsewhere. But it's important that you just sort of actively engage in the note-taking process. Like I mentioned a moment ago, in class, we'll do a quick check of your understanding, and then we'll do some hands-on. So your role, generally, throughout the entire term, is to arrive prepared, ask questions, work with peers, understand assumptions, and so on. So be actively involved and make sure that you're prepared. So if you're prepared, if you're coming to class prepared and well-informed, it'll make our time together in class really meaningful, not just generally, but also for your actual benefit. So I kind of alluded to this, but the way this is going to work in a flipped setting is not that I'm going to record a full hour-and-a-half lecture that you have to watch, and then we do an hour-and-a-half of in-class time together. Rather, we're going to be doing some fine-grained modules, breaking things down into nice digestible chunks, which is another way to kind of help the process along and kind of organize what we're learning. Every module will basically consist of 2 more or less 30-minute chunks for a total of an hour. The first 30 minutes or so is going to be these videos and reading that we're going to be posting online that you do before our class time. And then every module is going to have a 30-minute component we have in class. So every block we have together is an hour and a half. So we're going to be able to ideally fit in 3 of these 30-minute half modules into our in-class time together. How do we break down those 30 minutes that we have for a module in class? We're going to follow the 4 Ds. Diagnose, then we do, then we debrief, and then we decide. And I'll describe what that means in a few moments. So there's going to be 65 modules approximately through the course, give or take. And again, each of these modules will consist of a at-home version where we get the theory, we watch videos, we do some prep work, and then in class, that's when we do this sort of diagnose, do, debrief, decide sort of cadence. All of these 65 modules aren't just a flat, long list of different modules, but they'll be grouped into topics or higher level concepts. So topics might include something like cleaning and preparing data. Math and stats is crucial to data science. So it's a big topic, and each of those topics will have a couple of component modules to it, which we'll gradually build throughout the semester. I'm going to show you a website in a few moments. When you click on the website, you can kind of see how everything's broken down into this sort of tree-like structure. As I mentioned before, we have this in-class 30 minutes for every module with the 4 Ds. The first step is diagnose. So that's where we just basically check our understanding of the topic. So any questions you have from watching the videos, I might have assigned you a little bit of work to do at home. We would quickly, in about 5 minutes, just diagnose our understanding of the topic. Questions would come up. We'd quickly iterate. The main part of these 30-minute modules in class are the do component. This is a small activity where we practice understanding. I mean, occasionally diagnose might extend to the full, first 20 minutes or so, but generally do will take about 15 minutes. I might post some code for you to play around with your partner, which we'll talk about in a moment. And then after you do this little activity, then we debrief. That's when we all kind of discuss our experience with the do activity. And then given that, we might have bumped up against some problems. We might have had some unexpected or expected successes during the do activity. So that's when we decide. That's again when you go to your notes and basically just make a comment to yourself of what you need to do in order to master that module. What next steps do you personally need to follow? So this is the website. Hopefully you've all seen this by now. I am also constructing this from scratch myself. I wanted some flexibility here in how we deliver all of this material, and I wanted to organize it in a way that's a bit more straightforward. I'm just going to click on this link down here and hopefully take us to this page. Hopefully you can still see it. Yep. So this is very much in flux. So I'm actively working on this currently. For example, right now, the video you're watching now should be linked up here somewhere in the course operations. The course operations frame over here has a syllabus, which hopefully is linked. Not found. It'll be linked by the time you watch this video. Information about Dalhousie, about declarations of absence, academic dates, a little bit of information about the class, when it's delivered. This is all old information, by the way. I'll fix this also by the time we meet, and some policies. This is just kind of top of mind stuff. The main activities will be down here at the bottom. So here we have all of the modules. This is subject to some change also, but here we have, for example, the visualization and storytelling topic or concept. We'll break it down into modules. Each of these little buttons here, which are so far not available yet to you, will be a module. It's locked currently, so we're going to see like the visualization grammars, perception pitfalls. Matplotlib is a library in Python, so we'll talk about axes and figures and stuff like that during this module. When you click on one of these modules, this will change over here. So everything's changing. So this is gonna be a new video I'm gonna post in a moment. You'll have like a link that you can copy, so you can share this link to this module. Open All will open up. There's gonna be some other files that are linked down here. Like the HTML, the slides for this module will be posted. So you'll open all of them up. This is sort of a progress marker for how much of the class has been presented so far. Next recommended, we'll click. We'll bring you either to the end of the topic that you're currently in, or to the latest module that's been posted at all. If you're searching for something here, there's a little search module, so you can search for Python, for example, and you get the modules that are concerned with Python. If you care about weeks, this will tell you, we'll break things down by week. There are going to be some changes, so I'm going to change this to, instead of saying week 1, lecture 1, we'll have the actual module numbers here, for example. So this is very much in flux. Modules will have different kind of aspects to them, so a lot of them will be theory-based. This is where, I'm teaching you a concept, and we have a video about that concept. We'll have an in-class activity about that concept, but it's largely theoretical. It's largely about new skills or new knowledge. Occasionally there'll be labs. That's where it's going to be more of an activity that you might have a take-home component, you might have a in-class component, but it's more of a laboratory that a bit more involved than the do phase of the modules. Quizzes are going to be quizzes where we literally do in-class quizzes, which are 4 marks. And I don't think we have any projects in this class. Here we go. There's going to be like a small project that we might have partway through the semester that's related to some assignments, which I'll talk about in a moment. Anyway, all the videos will be posted here. You'll be able to click on them. The playlist will be on YouTube at some point. So hopefully this is pretty self-explanatory. Somewhere here, there's going to be a link to a tree-based structure for this also, so you can see things by a tree. There's some components down here. So we're going to have teams in this class. This is all dummy data for the moment, and I'll explain what at least the leaderboard means in a moment. So each of you will be part of a team, and through your acquisition of points over the semester, you'll rise and fall on this leaderboard. So you want yourself and your team to be as high on this leaderboard as possible throughout the semester. And then there's just some information here about licensing. So the licensing here is the GNU General Public License 3 for the code, and all other material is CC BY and CSA. Anyway, back here we are. So if you have any questions about any of these things, there'll be lots of time to discuss it in the future. Teams. I mentioned teams a moment ago. So everyone will be put into groups of 2 or 3 students. I'm going to do this myself before the semester, and there'll be a bit of time to refactor things in the early parts of the semester. One of the reasons why we want to form teams is that there's evidence that you personally will learn faster through explaining concepts to your teammate and to others, by critiquing the others' work and your work collectively. Building tools together is going to be much more beneficial for you than just doing it all on your own. Having small teams ensures that everyone is actively involved and kind of keeps an eye on each other. So that's why we're not doing larger teams. One of the reasons why we're not doing larger teams. The team will produce lots of artifacts, lots of things that you will submit. Some of these will be reproducible notebooks, a Jupyter notebook, which we'll talk about in the next module, or the next module. Sometimes it might be a figure or a table I ask you for. Sometimes it'll be like a one slide or one paragraph decision record. It'll be a material that I'm going to ask you to submit over the course of the semester. And each of these will count towards the points that will help you on the leaderboard. We're going to ensure that you can't just submit like a whole lot of extra stuff just to sort of juke the stats or game the system. You'll get a maximum number of points per week. The idea here is really to make sure that you're submitting quality work and not just a lot of work. Quality over quantity, or quality over volume. That's basically it. I also have a link to the Hawthorne effect here. So the Hawthorne effect, we'll see if it comes into play. The idea is that people are on their best behavior if they know that they're being watched, so to speak. And in this case, you're being watched by your teammate, and you want to do a good job collectively. So I think this is going to work out really well. In class, especially during the 4Ds, we'll have this sort of, one person might be actively transcribing or actively working in the Jupyter notebooks or the code that we'll be working on. So one person will be like driving on the keyboard. The other one might be going online, looking up resources, looking up answers to questions, looking at slides to try to, guide the theory. So we'll have different roles for different members of the team whenever we're doing things together. I just recommend that you rotate the roles periodically and make sure that you're not just devolving into only doing one kind of thing throughout the semester. So here's the leaderboard I mentioned a moment ago. A leaderboard basically translates into how much you're actively involved in this class. It will reflect the pre-work you've done, lab completions, any kind of help you've done. So there's going to be a forum that you'll be able to ask and answer questions. Even if you help somebody in another team, that's definitely a good thing. It's competitive, but it's not competitive to the extent that we lose our humanity. So if someone in another team is really stuck with something, it's still good for you and your team to help them out in a way that's open and avoids academic offenses, which we'll talk about a bit later. You'll also get, more points for doing the submissions well and fewer points for just doing the bare minimum. I think we talked about this already. A lot of these things have already been mentioned. So today, I just want to make sure that you understand who your team is. If there's any questions about modifying your teams, feel free to ask them. You should have a common way to talk to your team. I think a lot of Dalhousie specifically is on Microsoft Teams. So I think Teams might be a decent way to just make sure that everything's being discussed. I'm aware that there's a Discord that undergrads use. So whatever the method is, make sure that it's consistent. And ideally, it's going to be a situation where you'll be able to bring me in and answer questions and see discussions and things of that nature. Okay, you should probably be meeting as a team about maybe say 15 to 20 minutes per week for a check-in to discuss the material in the class, to discuss the work that we're going to be assigning you. So it can be more than this as well, but make sure you're just connecting as a team as much as possible. The syllabus is here. I think this one links to the correct one. Yep, this is the correct syllabus. You've seen this. Here's the correct logistics. So we meet Tuesdays and Thursdays, 8:35 to 9:55. A good time in the morning to be actively engaged at the psychology building. So I'll see you in soon enough in that particular room. I'm Frank Ridgich. You can click on this link to see my personal, professional website to learn more about me. I work in machine learning. I'm a member of the Vector Institute. I'm the director of the Atlantic AI Institute here at Dalhousie. I have worked in natural language processing, including large language models, in AI and healthcare. Several of my students have gone on to form successful companies in AI and health, and increasingly I'm interested in robust AI, safe AI, and methods to ensure that the AI that we're deploying is as safe as possible. So key dates you probably know about already. The first lecture is the 8th of January. The last lecture is the 9th of April. And the span between these dates is going to be a fun and amazing time together. So this is at a glance. There might be some small tweaks we have to the assessment. Generally, there's going to be a 10% participation in discussion. We kind of touched on this earlier. This is largely team-based, and it's tracked on the leaderboard. So if you come to class and you are actively engaged and you answer questions in person, online, and so on, and you keep on submitting these small activities, this will be good for you, and this will help track your position on the leaderboard. There will be weekly quizzes. This is done individually. This is done in class only. The lowest quiz mark you have is dropped. In the others form, this 25%. How well you do on these quizzes is also tracked on the leaderboard. So make sure your team is showing up, and make sure your team is doing these quizzes well, because that's going to boost your ranking on the leaderboard. There's going to be some practical assignments. These are take-home. These are things that are done over time. These are largely programming-based. These are team-based. There's going to be 5 of them, and they're weighted, as you can see here. The idea is that if you do really well on an assignment, that assignment is going to be worth more, up to 9%. If you do relatively poorly on an assignment, for whatever reason, that will be weighted relatively low as 5%. This is a progressive way to kind of make things a little bit fair for those who have an off assignment. There will be an in-class midterm, which is done individually and is tracked on the leaderboard, and then a final exam, which is also with 15%, also done individually and is not tracked on the leaderboard. Sorry, this cut off at the bottom. I'll make this scrollable by the time I post them. So here's the big buckets. This is more or less the concepts or topics I mentioned earlier for this class. Initially, we'll talk about foundations of data science, so what data science actually is. We'll talk a lot about Python, which might be new to an awful lot of you, including libraries. The pandas library will be used quite a lot for doing data science and data manipulation. This will also include some basic steps like how to clean data so that it's useful to us. We'll then go into statistics and inference and mathematics. This includes some probability distributions, how to test hypotheses in a scientific context. We'll ask questions, and we'll understand the differences between things like correlation and causation. Both correlation and causation can be expressed mathematically. They mean very different things. So we'll elucidate that through this section. And we'll talk about why this is so important. We'll start slowly and gradually ramp up the math and stats, but having strong mathematical foundations and tools in your toolkit will be important for you, both as just a scientist and as possibly an engineer in your careers. Once we have a good mathematical foundation, we can really sink our teeth into machine learning basics. This is going to be basic, so we're going to talk about things like regression and basic classification and clustering. There'll be other classes in our curriculum at Dalhousie that will go deeper and deeper into deep learning, for example. We might touch on that briefly later in this course. We'll then talk about networks and graphical data through means like Network X. So this is sort of data that's kind of structured in a way that, in which every data point is related to others. This can be, for example, in the form of social media data. And then we'll wrap up by something that is extremely important, just ethics and responsible data science. So to do this effectively, we're going to have to make sure that we're free of bias, that we're respecting privacy, and that we're respecting proper communication. So I'm going to introduce you, if you haven't seen these already, to a lot of tools. So by the end of this course, you'll be a very proficient Python programmer, and you'll have a lot of experience with several libraries. I mentioned pandas a moment ago. NumPy is a library of numerical functions useful for numerical analysis. Matplotlib and related libraries are going to be useful to make figures, animations, interactive graphs, really make the communication channel of data science effective. And then later in the course, we'll see scikit-learn, which is a library that is used both for fundamental traditional machine learning, but can also form the foundation of deeper machine learning. We're going to use Jupyter Notebooks. So Jupyter Notebooks, we'll see in the next module, is a way to kind of interact with your code in a way that's well, as I mentioned, more interactive. And we might also touch on kind of good software engineering practice. So version control through Git, GitLab, GitHub, even local Git. You can run it locally if you want. We might not, but I'm very partial to Podman and containerization and environments we'll talk about in the module 2. But ways to kind of make sure your code is shippable, that it's validated and it's shippable and it's deployable. That's going to be a very important component of this course as well. And finally, I'm just going to mention that AI tools and attribution. So there's going to be some text in the syllabus about academic integrity. I really recommend, especially now that you're in year 1, to read it thoroughly and become very familiar with integrity. So AI tools are permitted for learning. You might want to use it to replace Google, which is AI technically, but you might want to use large language models to help you identify resources, to help you answer questions. So fine in general. I always recommend that you double check whatever the large language model is telling you. Don't take it as face value. Just like in other avenues of your life, try to find like independent sources to kind of validate and verify what's being told to you. Some assessments may prohibit the use of AI tools. So when you are doing coding work, largely we're going to demand, request, and require you to not use AI tools in submitted work. And obviously a lot of the quizzes we're going to be doing in class are going to be done by hand with your laptops closed and your other devices put away. If you are going to use AI tools in situations where it's permittable, you will acknowledge every tool used. In any kind of chat log that you've had within a large language model, you will include that, links to that in your submissions so that we can double check. It's not just large language models, so copying and pasting code from blogs, traditional websites, coding websites, will also require attribution. The rule of thumb is if anything comes from anywhere else, a research paper, a blog, a video, anywhere, you want to be able to cite it and say, I got this information from this location. That's good scientific practice, and it's good ethical practice as well. If AI is absolutely prohibited and you use it and we catch you that this is an academic offense and there are various consequences for academic offenses. I've been involved in several of these, one or two here at Dalhousie and many at my former institution, and it's a big deal. So throughout this course, we're going to be emphasizing ethical aspects. I recommend that you treat this as not just a hurdle that I'm putting up in front of you for you to jump over. I want you to treat this class as a means of becoming a more fulsome scientist, a more fulsome engineer, and eventually a more fulsome leader. So try not to veer too much into using too many tools. Develop your own mind, develop your own skills, and you'll benefit that much more from it. Thanks so much. On to Module 1.